Hello everyone, I hope you all are good and you all are practicing questions. Let us for now do this one. This is going to be a simple question but a still interesting one. So let us start. Question में ये कह रहा है we have a rod of mass m length L and friction coefficient between surfaces surface of rod and surface of incline is 0.9. Inclination angle is given. We are asked what will be tension at the middle point of this rod. So how to go around this question? इसको समझाने के लिए simple एक example लेते हैं. If there is a rod, let's say it is kept over here, and this is given a force of F in this direction, let's say, and under the effect of this force, this rod will move, right? Let's say there is no friction here. Let us take the simplest case. So iska mass आप m ले लो. What will be the acceleration of this rod thing? Every point of rod will go forward with the same acceleration. Done it? Because this is a solid mass. So acceleration will be equal to F by m. Now, if we are asked to calculate tension at any point, let's say at this point, then what we will do? We will break this one system into two parts. One part this, another part this. Pick any one part. Suppose कर लो मैंने इसको pick किया and let's say this part has a mass of m1. ठीक है? So on this part m1 there is only one force acting, that is tension at this point, right? Tension always acts away from the body, so away from m1 I have applied, and this body m1 is also moving forward with acceleration a, so t will be equal to m1a. And m1 we can calculate based on at what segment we are asked to calculate the tension, so we can do that according to whatever is given in the question. यहाँ पे अगर हमारा रॉड मूव कर रहा है, we can apply the same logic. We can break the, I mean, we can first calculate acceleration of rod, then we can break it into two part, work on any single part and calculate. I mean, take any single part, write its free body diagram, write its equation, calculate tension, right? Because this broken part will also move down with acceleration A. Actually, it is not getting broken down. Just for calculating tension, we are breaking the system, okay? So in that case you will be able to calculate tension. So first of all, let us see if this rod is in motion or not, and for that you will draw first the FBD. So one force acting is mg, another force acting will be normal reaction perpendicular to the inclined plane, and since this rod has tendency to slip down, friction will act in the upward direction. We have three forces acting on the rod. Now if we are required to break the forces, then question is कि कौन से direction में break करें. ये बच्चों को काफी confusion होता है, तो मैं बता दूं, जब भी तुम्हारा body कहीं भी रखा हो, check for its tendency of motion, in which direction it has tendency to move. So in this case, rod has tendency to move along the inclined plane, so this line will become x-axis, and y-axis definitely perpendicular to it. So if force, friction force is along the x-axis, normal reaction is along the y-axis, mg is not along x and y-axis. It is not aligned, right? So we need to break it. If this angle is theta, this will also be theta, because if angle between two line is theta, angle between their perpendiculars is also theta. So in that case, this will become mg cos theta, and this will become how much? Mg sin theta. So what will be the maximum value of friction here? So F max अगर आपको लिखना है, आप लिखोगे mu n, and n value will be equal to how much? Mg cos theta, because this rod has no motion along the y-axis. Along y-axis it is in equilibrium, write it. F max आप क्या लिखोगे? Mu 0.9 into n, that is mg cos theta. So m into 10 into cos 37. Cos 37 is 4 by 5. So 0, this will get cancelled, and this will become how much? 36 m by 5, so that is 7.2 m. This is the maximum value of friction force operating here, that can operate here, right? Now let us see what is the external force mg sin theta acting, because in response to this only friction will operate. If this is greater than 7.2 m, then friction will be at its max 7.2 m. Let us check for it. M का value क्या है? M, G is 10, sin theta is 3 by 5. Sin 37, 3 by 5. So this is 30 by 5. So this is 6 m. Now this external trigger is less than that of maximum friction that can operate between these two surfaces, right? It means friction is going to adjust itself to 6 m only, because that much is only required. Done it? And this block will not move. It is not going to move. So now the question is, this block is not moving. What will be the tension at the middle point? So you just need to now think कि tension arise क्यों होगा. Now let us go around it in this way. Suppose कर लो आपके पास एक rod है, ठीक है? And ये rod आपके horizontal surface पे रखा हुआ है, ठीक है? Horizontal surface पे रखा हुआ है, इसका मास m है. So आपको क्या लगता है टेंशन आएगा इसमें? नहीं आएगा, राइट? क्योंकि आप इमेजिन करो आपके पास एक स्प्रिंग है, नॉर्मल ऐसे रखा हुआ है सरफेस पे. There is no trigger on it. I mean, there is nothing pulling it in this direction. There is nothing pulling it in this direction. Tension will not arise, right? So there is no tension. अब आप एक काम करो, इसको हैंग कर दो. अगर आप इसको हैंग करते हो, आई मीन ग्रेविटी इज पुलिंग इट डाउन, ठीक है? एंड बिकॉज ऑफ दिस पुल टेंशन विल अराइज एंड each point will be, I mean, we'll be facing different pull, because if you talk about this point, it is getting pulled by this much mass, this much weight, right? And this point is getting pulled by weight of this much mass. So as you will go up, tension will keep on increasing, and tension will adjust itself such that it will maintain the equilibrium of this what this rod. बिकॉज मैंने बोला ना, अगर आपने यहाँ पे टेंशन निकाल रहे हो, इसके नीचे मास क्या है, लेट्स से स्मॉल एम. सो डाउनवर्ड फोर्स इज एम जी. टेंशन विल एडजस्ट itself such that टी विल बी इक्वल टू एम जी. इक्विलिब्रियम कंडीशन को मेंटेन कर रहा है, ठीक है? सो अगर इक्विलिब्रियम कंडीशन को मेंटेन करने के लिए, लेट्स से इसी केस में, वर्टिकल केस में ही, व्हाट आई एम डूइंग, I hang the rod, and at the same time, at each point, I applied some different external force such that whatever pull different point are feeling because of gravity is getting compensated by that external factor. And if that external factor is there at each point to compensate for gravitational pulling that each point is feeling, then there is no need of tension, right? तो टेंशन खुद को, वो टेंशन में आएगा ही क्यों, उसको जरूरत ही नहीं है, वो रिलैक्स रहेगा, राइट? सो मेरे कहने का ये मतलब है कि इस पॉइंट पे हाफ, अगर आप इसकी बात करो, इफ देर इज नो नीड ऑफ टेंशन टू कम इन टू द सीन, इट विल नॉट कम. एंड मेरे कहने का मतलब सिंपल ये हुआ कि अगर इसके इक्विलिब्रियम को मेंटेन करने के लिए, इफ फ्रिक्शन इज इनफ इन द अपवर्ड डायरेक्शन, देन देयर वोंट बी एनी केस ऑफ टेंशन. जैसे आप देख लो ध्यान से, यहाँ पे एट दिस पॉइंट यू आर आस्क्ड टू कैलकुलेट टेंशन, ठीक है? इसको ऐसे, इस पॉइंट से ब्रेक करो, इस सिस्टम को लो. दिस सिस्टम हैज अ मास ऑफ m/2. Now, what is this gravitational force acting? That is m by 2 g sine theta, right? And what will be the friction force acting over here? Friction force तुम्हारा क्या होगा? I mean, maximum friction क्या होगा? F max अगर आप निकालो, then that is m by 2 g cos theta into mu, right? This is going to be the maximum friction force, right? So maximum friction force का वैल्यू अगर कैलकुलेट करोगे, 0.9 into m by 2 into 10 into cos 37, that is 4 by 5. So this is going to be equal to how much? This is going to be 18 by 5 m. So this will be equal to how much? 3.6 m, right? So this is the maximum friction. And what is this m by 2g sine theta? So m by 2 into 10 into sine 37, that is your 3 by 5. So this is equal to how much? This is going to be equal to 3m. So maximum friction force is greater than that of external trigger. So friction क्या करेगा? Friction will adjust itself to 3m, and it will maintain that this thing is in equilibrium. So there is no requirement of tension to come into account for this purpose. Done है? So tension will be zero. ठीक है? Because friction here is helping the rod in staying at equilibrium, right? So tension का कोई case नहीं होगा. Tension won't be there. Requirement ही नहीं है. Done है? So you need to go around this question in this way. अगर acceleration होता, you could have written the equation, and if you are getting zero, it's fine. If you are getting non-zero, it's fine. Whatever you're getting is correct. ठीक है? So I hope you have understood whole the scenario. I hope you have understood everything. But if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself and keep on solving more number of questions. Bye bye. Take care.